Okay, so we've been looking at the distributive law, and in this problem set, for the next couple of problem sets, we're going to use the distributive law to help us simplify expressions. Okay, why don't you start off with doing these problems? We'll go over them in just a minute. Okay, so in this first problem, you multiply 5 times 3x, you get 15x. Second one, you see the difference between A and B? You have to use the distributive law on the second one, right? You do. Because these are not like terms. If you wanted to multiply it, you just have to use the distributive law and get 15 plus 5x, right? This number has to multiply each term. Now for the last one, part C, technically you could do it either way. You could use the distributive law, but my point is it's a good habit to always look to combine like terms whenever possible. That's just a really good thing to be thinking about. So I chose not to use the distributive law. I combined them and then I multiplied without the distributive law. I got 20x. Now that's what you would have gotten had you done it the other way. It's just a little more work, I think. Alright, so what we've been looking at here is that the distributive law is really two different rules, isn't it? If you go from product form to additive form, that's called to multiply, and that's useful when you want to multiply an expression out. And what we've been looking at recently is going the other way too. When you have something written in additive form and you want to write it in product form, write as a product, by definition, that's factoring. So it's really two different rules depending on which way you want to look at it. In this particular problem set, we're going to focus mainly on using the distributive law to multiply to help us simplify expressions. So again, look at number 1 and 2. Do you see a difference between these two? Well, this doesn't have any variables in it, but also you need to use the distributive. If you wanted to multiply this out, you'd have to use the distributive law. Here you don't. Here you could just combine like terms. Remember I was saying that. Combine like terms. Then you do the multiplication next. You get 9 plus 3, which is 12. Whereas here, if you're going to hope to simplify this at all, you're going to have to use the distributive law to multiply it. You see? This 3 has to multiply each term. The most common mistake, of course, is to forget to multiply the 7 by the 3. So make sure. Some of you might find it helpful to actually draw these little arrows here to remind you that you have to multiply each term by it. Anyway, you get negative 12x plus 21 plus 3x. Now you can combine the x's. You see? You can't combine the x's until you've multiplied it out. So the x's, well, you get negative 9x plus 21. Before we move on, you see also that at this first step, you cannot combine this x with this. You cannot combine the negative 4x with the 3x on the first step because it turns out this is really not negative 4x. It's actually negative 12x, isn't it? So it's kind of like you're following the order of operations as best you can. If you could, you would add negative 4x plus 7, but since you can't, the next operation you would do would be to multiply by 3. Alright, let's do a bunch of these, and I'll give you some to practice. So sometimes it's helpful to read the problem back. The quantity 3z plus negative 2 times negative 3 plus negative 4z. If you were to simplify this, can I add these together? No, they're not like terms. So the next thing you would try to do would be to multiply, and this negative 3 is multiplying a sum. That sounds like the distributive law to me. So you would multiply each term by negative 3. It doesn't make any difference if it's on the right or left, because remember the commutative law applies. If you wanted to put it in front, you could. But I'm just going to multiply it out. Negative 9z plus 6 plus negative 4z. Now you can combine the z's. I get negative 13z plus 6. Okay, let's do a couple more. This one, what would you do first? Did you recognize these are like terms? That's what I'm going to do. I'm going to add these together. 3z plus negative 2z is just 1z. Excuse me. And then you multiply it. This is just negative 5z plus 3x. I don't think you can do anything else. They're not like terms, right? How about this one? As I mentioned earlier, you're welcome to hit the pause button whenever you want. You don't wait for me. I'm going to give you some to practice, but you get more out of this if you try them on your own. Always you hit the pause button and see if you can do it first. That's a really good attitude towards learning this stuff. Always try it. You learn more that way. Can I add those? No, not like terms. Can I add this with this? Right? No, not yet. There's a negative out here, which means negative 1 times, remember? This means negative 1 times. So this negative 1 has to multiply each of these. If it helps you to draw a little arrow, go ahead. You get negative 2w plus 5 plus 2w. What do you get when you add negative 2w plus 2w? You get 0. What do we call those two numbers that add up to 0? Those are called additive inverses, right? Negative 2w and 2w are additive inverses. Final answer is 5. Okay, how about this one? Let's see. This one's kind of troubling. That bothers me right there. You see, it's 2 times the quantity x plus negative y plus there's nothing in front of these parentheses. So it's like, how should you interpret that? Well, what we're going to do, I mean, it turns out these parentheses are not really necessary, but if you wanted to, you could put a 1 in front. If you put a 1 in front, then that would, the 1 would distribute in front of each of them. And you'd still get the same thing. So what I'm going to do is just drop the parentheses. They're really not necessary. Here you do have to use the distributive law first. So now what do? I'm going to combine the 2x plus the 1x and get 3x. But what is 3x plus negative 3x? They'll all cancel. So all you have left is negative 2y plus y. I just get negative y. The problems get more and more involved, so it's really important to use your algebra skills. My advice is to, of course, write the whole problem down and don't try to do too much at once. It's easier to make a mistake that way. And if you get confused, read the problem back. This is 3w times the quantity 4 plus negative 2 times the quantity x plus 5. In your mind, you should look inside the innermost parentheses. Can you add those? No. So what if, according to the order of operations, what is the next thing you would try? Well, the next thing you would try would be to multiply the negative 2 by it. And you can do that, right? So this is the first step that we can do. We're going to use the distributive law to multiply this out. Now, this is also important. By the distributive law, when you multiply this out, those round parentheses go away, right? I mean, when you multiply that out, you just have negative 2x plus negative 10 in there. We're not able to get rid of these square parentheses yet, but when you multiply something out with the distributive law, the parentheses are gone, right? Okay. If you left parentheses there, it could be kind of confusing, actually. Now what? What would you do next? Inside the square brackets, I think you can combine the 4 plus the negative 10 and get negative 6. And then we could use the distributive law one more time, carefully. This 3w multiplies each of them. I get negative 18w plus negative 6wx. Okay, let's do this last one. We're going to work inside the innermost parentheses, which I believe will be right there. Can you combine those? No, they're not like terms. So according to the order of operations, what's the next thing you should try? Well, you should multiply. That would be before the addition. So use the distributive law here. Make sure you multiply each term by 2. So you get this. You get a negative 10 plus 6x there. And the x stays there. You write the whole problem down. Inside the square brackets, you add like terms. You get x plus 6x, which is 7x. Then we're going to use the distributive law again. This 3, don't forget, it has to multiply each of these. And when you multiply the 3 by each of them, what I was saying earlier is notice the parentheses are gone. That's what the distributive law says. When you use the distributive law, you don't need these parentheses anymore. In fact, if you put them there, it would be very confusing. Add like terms, this becomes a 19x plus negative 30. Very good. You're doing great. You really are doing great. Try these. Get a piece of paper out, hit the pause button, we'll go over them in just a minute. Okay, here we go. So, and this one, you don't need to use the distributive law, do you? I would just add like terms. That becomes negative 2 inside the parentheses. Now inside these square parentheses, you get negative 5 plus negative 3 times negative 2. That becomes a 6, right? So it's negative 5 plus 6, which is just 1. So your answer is negative 2 times 1, which is negative 2. This one, if you want to simplify this, you do need to use the distributive law because these are not like terms, either of these. So the negative 5 has to multiply each of these two. And the negative 1, remember this is a negative 1 here, has to multiply each of these. Now remember, when you use the distributive law, you dump the parentheses. There should be no more parentheses left here. You get negative 15z plus 10 plus negative 2z plus 1. Add like terms, you get negative 17z plus 11. Alright, this one. Did you look inside the parentheses and look to combine? You can add the 5xy plus the negative xy and get 4xy. And then you can add the negative 2x plus the 7x and get 5x. Now when you multiply, you just get negative 8xy plus negative 10x. Last one. This one's a little involved, but this is where you have to slow down and just use more steps. Inside the innermost parentheses, don't add those if they're not like terms. You can't do that. So the next step you would try is the multiplication. Remember, this is a -1 outside here. So you multiply each of these terms by -1, and you get to drop these round parentheses when you do that. You end up with -y plus -2. Everything else stays the same though, right? Everything else stays exactly the same. Okay, so inside the square brackets you got y plus -y. Don't those just drop out? And you get -2 inside the square brackets? So look inside the curly brackets now. You get 3y plus -3 times -2. You do the multiplication, you get a 6. Almost done. Last step is to distribute the -2, and your final answer is -6y plus -12. Alright, so in the next couple problem sets we're going to keep going on this. The problems get a little more involved. This is where you really have to do the homework. We'll see you next time.